Hi, welcome back to AP Calc review. So I'm going to go over some more definite integrals, this time using U-substitution. These problems were pulled from Khan Academy. Some people were having some difficulty with them, so I thought I'd work some of them out. So here's our first one. It is the integral of sine of 4x from 0 to pi over 4. And we can't take the integral of this directly because we can only take the integral of sine of u, du. So, we got to do some u substitution. Usually u is going to be something that's pretty simple that's inside of another function and that we can take the derivative of easily. So here we're going to let u is going to equal 4x. All right, and that's going to give us then a du. We got to take du. Du is equal to 4 dx. Now we've got to change our integral, change our definite integral here. So what we want to do is to rewrite this guy in terms of u. So first off, since we have sine of 4x, let's just write this in terms so we can see what the substitution is going to do for this one. We need to have a 4 dx here. And to get a 4 here, that means we've got to multiply by 1/4 on the outside to keep it all the same. So I'm not changing anything. I'm just rewriting it so I can do my u substitution. And now what? Now let's plug everything in. So this 1/4 is not going to change. That's our constant. Then we got sine of 4x. Well, 4x is u, so we got sine of u. And this 4x dx here, that's going to become du. So we got a du here. Now, the biggest thing you need to worry about is changing the bounds. So this one goes, the original goes from 0 to pi over 4, but that was in terms of x. So what we want to do is to plug these guys in to this right here. So if I take 0 and I plug it in here, I would have 0 times 4. Well, of course, that's still going to be 0. So that's my new lower bound, although it hasn't changed. And then I'm going to do the same with the pi over 4. I'm going to plug that into here for x. So I got 4 times pi over 4. And what's that going to get? Oh, that's going to give us, oops. It's going to give us pi. So now we can rewrite our bounds. They are going from 0 to pi. Okay, so now that we have the integral of sine of u, we can integrate. So the integral of sine of u is going to be negative cosine. So we got negative cosine of u. And still got this 1/4 the outside. We want to evaluate this from 0 to pi. And one trick that I showed you is when we have negatives here, one thing we can do to get rid of those is just to change our bound. So, change our bound. So it's going to be 1/4 of cosine of u, and then change it so it's 0 to pi here. And now we can plug in. So we got 1/4 parentheses cosine of 0. Where is 0? 0 is right here. Cosine of that is going to be 1. And if we go over here to pi, there's pi. Cosine of that is going to be -1. So we have 1 minus a -1, which is going to be 2 times 1/4 is going to give us 1/2. So we have an answer of 1/2. And I'm going to try to do another one here. Let me just scroll down. So move that up. So the next one I pulled up was the integral of 6 over pi to 2 over 3 pi of cosine of 1 over x all over x squared dx. So again, this is not a very fundamental function. We have to do some u substitution. What do we decide u is going to be? Well, u again is usually what's inside of another function. So what do we got in here? We've got a 1x, 1 over x inside of cosine. Well, you have to be able to take the derivative of it easily. We can take the derivative of 1 over x, and we should see that derivative somewhere else. So let's see if this is going to work. So let's see if u can be 1 over x. We could also write that as x to the -1. That makes it a little bit easier to find the derivative. So du is going to be negative x to the -2. Or what would that be? That would be the same as -1 over x squared. Well, lucky us, we got x squared over here on the bottom. All we need is the negative part. So we could rewrite this. So we have the -1 over x squared. And we've got the cosine of 1 over x dx. And it's going from 6 over pi. I'm not changing anything at this point. 2 over 3 pi. Just want to make sure that everything is going to fit perfectly. And so we have, now we can do our u substitution. And we have the cosine of u. That's there. We have our du. Oh, I had this negative sign added. I need to add another negative out on the outside so they balance out so it doesn't change from the original. So we have this negative and then a -1 over x squared. The -1 over x squared, that's going to become our du. And what else is going to change here? We have the negative on the outside. And we have 6 over, oh, no, it's not 6 over pi anymore. Remember, we've got to change those because those were in terms of x. And u, remember, is going to take the reciprocal. It's going to be 1 over x. So that's the reciprocal function here. Reciprocal function, 1 over x. So we can just flip these around, pi over 6 and 3 pi over 2. Now remember, we got this negative on the outside. If you want to get rid of that, you just have to switch the bounds. So pi over 6 can now go on the top. 3 pi over 2 can go on the bottom. Get rid of the negative. We have cosine of u du. And what is the integral of cosine u du? It's going to be sine of u. Sine of u. And the upper bound is, again, pi over 6. The lower bound is 3 pi over 2. Have to use your special triangles to get these. And think about sine of pi over 6. Pi over 6 is, 30 degrees here. What is sine of 30 degrees or pi over 6? That you should get 1/2. And then we're going to go over to 3 pi over 2. Where is that going to be? That's going to be, there's pi. Pi over 2 is going to be down here, 3 pi over 2. So that's going to be a -1. So we are subtracting a negative. Remember, it's always the top minus the bottom. So 1/2 is what we get on the top, minus, when we put 3 pi over 2, we get -1 on the bottom. So we have our answer, 3 over 2. And I will continue putting some more up, but I thought I'd make these a little bit shorter.